starting problem. It says f x y z is equal to 1, negative square root of z over y, negative square root of y over z. In moving the particle, so you want to work from 1, 1, and 1 to 10, and 3, and 3. So that's the problem to be done. And I just look at this and I feel a little weird, because what is it not saying? It's saying over any path. It's telling me. It doesn't tell me the line segment. It doesn't tell me anything. It says a path, any path from this point to that point. So I kind of feel this is path independent, right? As soon as I feel it's path independent, I suspect conservative fields. So I check the conservativeness of this thing, and I kind of find the potential function, and then I compute that way. So these are some of the questions. But then it tells you something else. It says within the first octant. Why first octant? Because domain of f excludes y equal to 0 and z equal to 0. Right? So the domain of f excludes these two lines in 3D. And so if I want to be conservative, I have to be somewhere that does not intersect either of these two lines in 3D. And so first octant is a safe place to be. This happens in your DFQ a lot too. You care about basically solving solutions for DFQ that excludes all the holes in there. So you just stay within on hold places, basically. So that's the story. And so quick check, find the curl of 1, find the curl of f, and the curl of f is this. Let me write this in a nicer way. I'm writing as negative z to power 1/2, y to power negative 1/2, negative y to power 1/2, z to power negative 1/2. And so I'm writing this as 1, negative z to power 1/2, y to power negative 1/2, negative y to power 1/2, z to power negative 1/2. And then when you take the, when you start computing, what do you get? Oh my, that's when the regrets comes in. That's this direction, and then minus that direction. And you get partial of with respect to z of z to power negative positive 1/2. So it's going to be 1/2. A negative went with the other negative sign, z to power negative 1/2, y to power negative 1/2. Oh, this is 0. Then you compute whatever multiplies j, and it gets to be 0. And then you compute whatever multiplies k, and it's going to be 0. So I did one of them, but you guys can compute the rest of them. They're very similar, basically. Oh, the rest of them are kind of easier, not very similar. Because let's say for j, you just partial with respect to x of the function that doesn't have any x in it, and minus the partial with respect to z of 1. So it's going to be 0, and the other two are going to be 0. Just the ith component was a little bit more work. So the curl is 0. Check conservative field. Now, the next part that I want to do after I found the curl, I want to find the potential to find the potential. And potential is just that story. I take the derivative of 1 dx, I take the derivative of negative z to power 1/2, y to power negative 1/2 dy, integral of negative y to power 1/2, z to power negative 1/2 dz. This one is going to be x. That one is going to be, guys tell me, it's going to be y to power 1/2, so it's negative 2, z to power 1/2, y to power 1/2. This one is going to be negative 2 again, y to power 1/2, z to power 1/2. The first one is C1 of y and z. The second one is C2 of x and y, x and z, and then C3 of x and y. And common terms is as a constant for the other one. So write the common term once. Now I did everything correctly, right? Hold on. Yeah, I'm okay. And then write the uncommon term. Make sure that it's a constant in other ways and write it once. Then the last step is put the n, q, and p. So f of q minus f of p is going to be whatever that is. Negative 2, z is 3 to power 1/2, 3 to power 1/2, plus 0 minus negative 2, 1 to power 1/2, 1 to power 1/2, plus 1. So this is going to be negative 6 plus 2. Did I do it right? I think I did it right. No, I didn't. What oh, there was a 10, not 1. This is 10, not 0. Okay, there we go, 10. Right? Now, 10 minus, this is 10. Let's redo it. Negative 6 plus 10 minus 2 plus 1. Whatever that is. I think it's okay. It's 5. Yes. Okay, got it. Feel like I'm going to fail my 3rd grade math at this point. Everybody okay? Move on to the Green's theorem. You ready? Okay, so let's move on to the Green's theorem. Okay,